Hi, this is Mark Kemper with EMS. In this video we're going to demonstrate the new Creaform HandySCAN. It comes in a 700 and a 300 model. Now Creaform's been around for a long time and known for its handheld scanners. This new scanner is really a big advancement in their handheld scanning technology. The first thing you'll notice right away is just how small it is. You can see it's very narrow, it's very compact, lightweight, weighs just over a pound, very easy to handle and scan. So like most of their scanners, the way this one works is you've got two sensors here in the front, basically cameras. Okay, and then here is where the lasers project out. Now this is one of the new and unique things about this new model, which we'll talk about here in the demo today. And then around the sensor you have some LED lights that light up the targets, which we'll show and talk about here shortly. This scanner, this is the whole unit here with a USB 3 cable, plugs into a compatible laptop or desktop computer. With the Creaform VX Elements software, which is basically the capture software. So again, very lightweight, very portable. This is great when you have to get out in the field and get into tight areas, such as a vehicle or inside a big, industrial pump or a big housing or anything like that. It's laser based, so that works very well on shiny and dark things. Also works in outdoor lights, direct sunlight. So that's very handy, or where you have parts that have varying color. Okay, and we've got some new buttons here on the back I'll talk about for handling situations like that. And again, very small and portable. Here's the case that it comes with. So you can see here it's very small. We can ship this overnight to all our different offices, for a reasonable price. I can get it shipped, overnight, and they can have it at the other office and get out in the field and start scanning. Or if we're going to go fly somewhere, I can check this into the overhead compartment on an aircraft versus having to check it as luggage. So again, very portable, very easy to use, as you're going to see here in the demo. Now, with the HandySCAN scanner, it requires targets on the part in order to scan, okay? And a lot of times people think, oh, targets, I'm going to have to target the part, that's a lot of work. It's actually really easy on most things, and then there's some other tricks I'll show you. The advantage of targeting the part is it allows many things to happen. One, I can move the part around because the targets are on the part. It's going to be looking at the targets and allow it to allow the part to move around. The other thing is targets improve accuracy. Even scanners that don't require targets, most people end up using targets with them anyways because they'll improve accuracy. If you're just doing geometry-based alignment, which is basically take a scan, take another scan, line them up. There's more room for error in those alignment processes, and the more you scan, the more error you can get. Okay, so targets are really a good thing, and they come in different formats. This is an aluminum part, so I'm using sticky targets. Basically, they come in a box like this. They self-dispense. I just pull this down, grab a target out, and place it somewhere here on the part. Okay, and you need the targets on a small part like this about every 3 or 4 inches. On something bigger, flatter, you might get away with larger targets. But so we have the sticky targets, we have magnetic targets, and then we have other things we use. So sometimes we have a small part or maybe a tall, long, skinny part. I might fixture up some target bars, have the part in the middle, and have maybe 2 or 3 of these bars. And as long as the targets are in the line of sight, it'll pick up the part, the scanner will pick up the part shape while it's looking at the targets. So they can be around the part on something like this. Sometimes we'll just have a small part and set it on a table like this that has targets on it. The only disadvantage to this setup is once you set it here, since the targets aren't on the part, you can't move that part around. Okay, so but again, the advantage of targets is, in this case, I've got a part that I've got to scan both sides of it. You're going to see me be able to do that all really automatically, where if I was using, for example, let's say an ARM-based scanner, I would have to scan the part and then save that file, flip it over, and scan it again. The problem with ARM-based scanners is the part can't move while you're scanning. The base of the the arm can't move, and you need a real, rigid setup, almost like a CMM, in order to keep your accuracy, because otherwise you're going to have multiple setups. You got to calibrate. If you're doing large parts, you need to do a process called leapfrogging, and all of that just introduces error. With targets, it just makes it easy to scan. So about a minute to target a part like this, and you're going to see the payoff, which is how quick and easy we can scan. So how targets work is it's really a process called triangulation. So just like GPS, where you need to see 3 or 4 satellites in the sky, scanner does the same thing. It needs to see 3 or 4 targets, at least that. Most of the time it sees more than that, and that can track its position as we continuously scan around. Okay, so as we go around, as long as it can see those targets, it'll scan. If it can't, it'll stop scanning, go to a different spot. And you can see the targets are actually random here on the part. You want them to be random. If they were all symmetrical, it would actually get lost. And then you can see I've got my part on a stand here, just a couple little blocks, and that just keeps it off the table because we're going to end up picking up some of that scan data, and we don't want our part kind of stuck to that. Just for editing later, it just makes it real easy to get rid of that data. You'll see it as we go along. So the difference between the 700 and the 300 model is they really look the same. It's just a few differences. One is this has an accuracy of just over 1/1000th of an inch, where the 300 model is just over 1.5 thousandths. This has 7 laser lines, which is split, so it's actually 14 laser lines, which you'll see here in a minute, and the 300 has 6. And this also has a single line mode, which I'll show you in a minute. So a little faster scanning, a little better accuracy in the 700 model. But basically the way it works is there's a button on the back, and we literally just click the button once and we start scanning, and you can see all the laser lines, and as I move around the part, you're going to see the targets will either be white or red. So as it acquires them, red it's using and white it basically knows about. So you can see how quickly I'm moving around this part, okay? And we'll move up and down. Now we're going to get to an area here where it's bare metal. It's real shiny, okay? And it's actually doing a pretty good job. But at any time, I've got a couple different things I can control here. One of them being the shutter. And what that does is it slows down or speeds up. In this case, I want to slow down the shutter speed, and I want to increase the laser power. So when I have dark or shiny surfaces, I want to be able to do that. The downside is I've got to go a little bit slower because it can't capture the data as fast. But again, having this mode where I can turn it up and down just right as I'm moving along, so now I've already got that area, I'll crank it down a little bit, and then you can see me moving along. And like all scanners, it's line of sight. So as I move around, we want to definitely aim the scanner kind of perpendicular to the surface. That always gives us the best data. And again, having the freedom of the movement of my arm, it's very easy. You can see me, if I want to get, for example, this wall in there, I just crank that over, and you can see it picking that up. You can basically see it picking up that flange or that lip, whatever you want to call it. Now the other thing this has is this single line mode. Okay, and what it does is it orients a single line perpendicular to the lenses, and this is really good to get into narrow cavities. Scanners are not only line of sight, but basically the sensor has to see the light source. So when you get to something narrow, they basically never converge. They never see each other. So by orienting it perpendicular to the cameras and just doing a single line that the cameras focus on, you can see I'm getting down in this narrow area, getting down in these, and again, just a click of a button and I go back. So I can adjust the shutter on the fly, I can zoom in and out on the fly, and I can go to that single line mode all without stopping scanning. But the beauty is I can start and stop anytime I want. So if I stop, have to do something, and let's say I forgot where I was, it doesn't matter. Okay, I jump back over here, you can see it automatically orients the data to that position, okay? Because again, the randomness of the target. So you can see I'm pretty much done, probably doing more talking here than scanning, but just, I go around. Now, once I'm done here, I need to get to the back side of the part. And again, this is where targets really work out well. So what I'm going to do is I'm going to lift the part up. I'm going to kind of hold it like this. I'm going to go back to a known spot, which in this case works out real well right here. And I'm just going to start slowly moving around. And what I'm going to do first is I'm just going to kind of scan it to grab the targets. Okay? And again, you can see the beauty, even though I'm sliding the part all around, it's still tracking everything. Okay? And again, I'm going to put my little stands back on the part here, and that's just to keep it up in the air. It just makes it easier later when we go to edit the data that I'm not connected to the table. Okay? So again, even though the part's kind of loose and falling around, doesn't matter. Now I can just keep rotating around and scanning. And you can kind of see all that table scatter data. That can be a real pain to clean up. But again, by just putting a few little stands underneath it, it keeps that data separated from our part data. So it makes it super easy. Okay? So again, it's so easy to move around. I can even have the part moving as I'm scanning, which is really unheard of in a lot of different scanners. Okay? So it's continuous scanning. We're capturing up to, in this scanner, 480,000 points per second on the 700 model and 206,000 on the 300 model. Okay? And again, I can go to that single line mode. I know it's probably hard to see up there because I've got all the scatter data. And you get that from the table. Some of the shiny areas are going to reflect some of the data, but it's just kind of out in space. And shortly here we'll go to the software and you'll see how easy that is to clean up. So I can go in that single line mode, and it's kind of like digital spray painting. I just keep working my way around the part. I don't have to worry about over scanning the part. It's not going to hurt anything. I'll show you in the software how it takes all this raw scan data and processes it, but I can get down in these holes. And again, anytime I want, I can go back to that 14-line mode. So, you know, it probably took me as long to target this part as it does to scan the part. Now, of course, I've been kind of talking as I'm scanning, but I could target this part in a minute and scan it in a minute, minute and a half, maybe 2 minutes at the most. And I can stop, I can look at the data, see some spots I missed, go back. Also, you got that the green bar, that just shows me if I'm too close or too far away. There's also a readout right here too, okay? So you can see I'm getting too close, it turns red. If I get too far away, it just shuts off. It'll just stop scanning when it can't acquire targets. I come back in. So it's pretty easy to use. You don't have to be a CAD expert to learn how to use this scanner. Some basic training, basic techniques, and you can go out and send really anybody out to do the scanning. So I just keep going along until I think I'm done, and then I'll stop and we'll process the scan data. Okay? And again, I could take the part if I thought maybe I missed a spot on the other side, or maybe I want to stand it up on end like this. And continue scanning. So it'll jump around. Again, because it's all line of sight, all scanners are line of sight, it makes it great to be able to just hit it at every angle to make sure I've got all my scan data. Okay? So that's really it. Very easy to use, very small, very portable. It's really getting the kind of metrology grade in a handheld. Very, very high accuracy. Just over 1/1000th of an inch was unheard of, not too long ago in a device like this. So very easy to use, small, portable, laser-based, which is good to do those dark and shiny surfaces as well as other types, all in a nice package. So what we'll do next is we'll go into the software, we'll actually look at the scan data, show you how to clean it up and get it ready for downstream applications like inspection or reverse engineering or some other process we may want to do. Okay, once we're done scanning, we typically want to do some cleanup before we send it down to applications for reverse engineering or inspection. So for example, we have all that scatter data, we'd like to get rid of that, maybe optimize the mesh, fill some holes, things like that. So the VX Elements software has this panel over here on the left that allows you to do quite a few things and fairly automatic. So for example, remove isolated patches. As I slide that up, you'll see that data will all disappear. So because it's not connected to the part, it's easy for it to figure out what to get rid of. We'll want to autofill the holes a little bit. That's just any small areas we missed. For example, it'll try to use curvature-based hole filling. The more we slide that, the more aggressive or larger holes it'll try to fill in. We're going to want to decimate the mesh. So for example, if we turn on the triangles, right now they're evenly spaced, but that's not very efficient. In flatter areas, for example up here on the top, we don't need all those triangles, but yet we do want them on these corners and other curved areas because we want to preserve that shape. So we'll go ahead and slide the decimation up a little bit. And again, the more we slide that, the more aggressive it'll get. We'll want to fill positioning targets, meaning everywhere we had targets, fill in behind it. And again, that'll be curvature based. So those are the main things we'll want to do. And there are other things you can do in here. You can do some very basic CAD creation like planes, circles, points, spheres. You can do some basic measurement, but that's about it. You know, everything else we'll want to do is going to be downstream. So we'll go ahead and hit apply. And before we do that, take a look at our triangle count, which is almost 3.3 million triangles. You know, so let's see how everything does and how our data looks. So we'll go ahead and hit apply. And this will take a few minutes to process because it's got to work through a lot of data, and we'll see what the results look like. Okay, so it's completed. Let's take a look at it. Our triangle count, you can see now is down to 566,000. If we turn back on our triangles, again, you can see much bigger ones in the flats, but yet in the curved areas, still keeping smaller triangles and preserving that. Let's set that back. So we can take a look at it. Everything looks good. You can see it filled in some of those holes. So we're ready to export it. So typically what we're going to do is come under Files, Export, and we'll export a mesh, which would typically be an STL file, to go ahead and send it downstream. Okay, so we have now imported that scan data into Geomagic Design X. Which is a standalone reverse engineering product. They also have a product called Geomagic for SolidWorks, which runs integrated right inside SolidWorks. But if you take a look at it, here's the raw scan data. Now, the common misconception is that this is CAD and you can do stuff with it, and it's really not. It's just that polygon mesh. So it doesn't understand that, you know, this is a flat plane, and this might be a cylinder, and this is a hole. It is just dumb scan data. In addition, this is the manufactured part. This is not a CAD model. So any changes that were made for the manufacturing process, such as draft and parting lines and various things, that all shows up here in the scan data, but typically a lot of times that's not in the CAD data. So reverse engineering a part into CAD is a process. People think that you push some button and you get a CAD file, and that's just simply not the case. So you take a part and look at a part like this, you've probably got 1 to 2 days of work to actually build a feature-based solid model. So for example, let's just walk through this history tree. So this is history tree modeling, like most of your solid modeling products. There's sketch 1. So it's a process of creating sketches and extruding and lofting and cutting and so forth. And if you walk through, you can kind of look at how this was built. So it's a whole series of sketches and extrudes and lofts and cuts, etc. And you know, the more features on a part, just the longer it takes. Now the advantage of this software, though, is you get to use the scan data to extract your sketches and, you know, build all your geometry. So it does make the process certainly go faster and certainly will be more accurate. So if you go through this whole tree, there are about 66 different features, sketches, which then basically usually creates a feature. So there was about 66 features built to create this, the solid model. Okay, this is real CAD. This is a plane. This is a cylinder. This is a face, etc., etc. This is something that you can, you know, manufacture, because what you're going to do in this process is, you know, you're going to make things perfect. You're going to make things flat. You're going to make things perpendicular, etc. Because if I turn on the deviation map, comparing the CAD model to the raw scan data, you're going to see differences. Okay, so for example, up on this face, you see green, which in this case, I believe is everything within, you know, a few thousandths of an inch. You can see part of it's green and part of it's blue. So that's telling me that that scan data was not flat, because when we created this CAD entity, we made it flat. Okay, but you can see here everything in green was within that tolerance, and over here in the light blue it's actually undersized. But that's very typical. When you scan something, it is not perfect. Again, you can look down on this face and see the same thing. So when you're reverse engineering, you have to make a lot of decisions about, you know, what the design intent was of the manufactured part. Okay, so reverse engineering is not a push button. It can take hours to days to weeks, depending on, you know, what you're working on and the complexity of it. And there is different software. It will be faster and certainly will be more accurate than trying to manually measure it. measure it, but again, it is not a push-button operation. Okay, now if you were going to be doing inspection, typically you would already have the nominal part, and you would just import the scan data and then create your inspection report. So here we'll just show you what an inspection report looks like, in this case saved out as a PDF. So we've got the initial nominal CAD file, we have the scan data, then typically you're going to do an initial alignment, and then usually from there you're either doing a best fit or in this case a datum alignment. So you'll call out your datums to align the part. And then here's a quick 3D compare, kind of showing a color-coded map and some worst measurements, both plus or minus on the part. Then you can, and that's them called out here. Then you can get into full GD&T. You can see some positional callouts here and all the resulting data, some other callouts here, etc. Here's another positional on this pattern, and so forth. So here's a dimensional measurement. You can look at flatness. Basically, all the GD&T and any dimensional callouts you want to make can be done, and then usually printed out in these reports. So for inspection, you're typically not creating the CAD. You already have it. You're bringing in, aligning it, and putting the data together and creating a report. Since this video came out a few years ago, Creaform has actually introduced a new version of the HandySCAN called the HandySCAN Black. We have created some new videos showcasing some of the new features and benefits of the new HandySCAN Black, and I would encourage you to check out those videos.